The following podcast is a proud member of the Blue Collar Roots Network. Find all the shows by visiting bluecollarroots.com. Think of this show in this way. Rush Limbaugh and Howard Stern had a child, and that child grew up to have a podcast about building science. This is the opposite of that. Here's Bill Spohn.
Hello and welcome back to another episode of the Building HVAC Science Podcast, where it's our goal to help create better, more knowledgeable HVAC and building performance technicians by helping these two professions to better understand each other with the ultimate goal of making customers happy in the homes they live in the buildings they work in, and also to have some sense of satisfaction when you do your job and you get that good feedback from your boss, from the employer, from your colleagues, and maybe internally from yourself. But today's topic's got an interesting title to it. Residential HVAC design has not changed much in 20 plus years. We'll be hearing from Russ King. He's a rare breed, really. He's equally an inventor, author, both technical and fiction-based works, software developer, design practitioner, instructor, and installer. Above all that, he's passionate, thoughtful, kind, smart, and loves to share what he knows. And that sounds like the Boy Scout oath right there. If you get a chance, you really need to see Russ present sometime. Online, whatever, or look at the books he's published. You can find Russ on LinkedIn at a link in the show notes there. And he's got a really cool blog with an awesome tagline offering good advice, whether you want it or not. And the link to his blog is also in the show notes. Russ and his son Connor have also developed an awesome modeling tool for HVAC called Quix Model. That link is also in the notes. Russ has got an awesome sense of humor, and it comes out in just about everything he does. Hopefully you'll hear a smile in his voice as we're having this conversation. I had a great time interviewing him, and I really look forward to getting your feedback on what you thought about Russ King after you listen. Let's get to it. Hey, today I have my good friend, I'm going to call him friend, Russ King, here with me today. How you doing, Russ?
Yes, hi. Great to be here.
Great. I love a guy with such a succinct name. 4 letters his first name, 4 letters his last name.
Yeah, it's easy to pronounce.
And I think we'll be talking about a 4-letter acronym today, HVAC, right?
Yeah, definitely.
So I'll just dive right into it, and then we'll come back around and talk about Russ's background and why he can make statements like this. but Russ has offered the topic sentence here, HVAC design hasn't changed that much in 20 years. That's a nice, challenging thought to pursue. So why do you think that?
You would think it has, but the basic process really hasn't. And the problems that we're having today are essentially the same problems that we had when I first started doing it 30 years ago, even. Just communication, having installers trust the designer, the architect not giving you space to run your ducts. Those haven't changed at all. We have new software available. There's new equipment available, but the process hasn't changed much at all. Manual J, the way the loads are calced, Manual D, Manual S, the essential process has not changed much at all in all those years. And they're in the middle of a big committee right now to rewrite Manual S, and Manual J gets updated every so often, but it really looks very much the same as it did 30 years ago. And so I probably could have said 30 years that things haven't changed much. But when I first started doing it, there was no software at all. It was all worksheets. And so that was a big change. When WriteSoft first came out in the 90s, that was huge. And even just people writing spreadsheets to do it for you was a big deal. I would say ever since the first software came out to now, it hasn't changed a whole lot.
So all worksheets. Okay, now let's explore your background. You gave me a fairly nice overview of it, but I'll let you kind of walk us through it in your way, your style. How did you get started in this technical field?
My college degree, I went to Humboldt State University, which is on the north coast of California. It's kind of a long, funny story how I even ended up there. I originally wanted to be a wildlife biologist. Humboldt State was very well known for that. And chemistry and biology kicked my butt. And so I realized I was better at math and physics and switched over to the engineering program up there. They have a very unique engineering program. It's called Environmental Resources Engineering. And they have several emphasis areas. And I chose energy. And that's just how I got my degree. And so after I graduated, I started back then, you'd go through the yellow pages and look for companies. My wife was a school teacher. I met her in college and we were engaged. And whoever got a job first, that's where we would move to. And so she got a job in the Sacramento area. And I just started going through the yellow pages and looking under E for energy and engineering. They were right next to each other in the yellow pages, and ended up getting a job with a company called Davis Energy Group in 1988. And my first boss, his name was Marshall Hunt. He's a very smart man. He was my mentor, and he pretty much taught me everything I know about energy and HVAC, at least back in the early days. And he was the very first ACA certified instructor in California. And he was really big in the California Energy Code. He was a licensed mechanical engineer. And I ended up getting licensed as a mechanical engineer under him a few years later. And we were doing ACA manual JS&D by hand for a few builders. We started off doing for custom home builders, and then a couple production home builders asked us to do it. And we were drawing everything by hand. We were doing all the calculations by hand. And then it started getting more and more popular, and the utilities started asking us to teach classes on HVAC, residential HVAC design. I should be more specific on that. Honestly, I have very little commercial design experience. I've just fallen into the residential side of it, and it's sucked me up. I haven't had much chance to get out of it, but it's fine. I enjoy it a lot. Between the energy consulting and the HVAC design, that's where you really learn that a house truly is a system, how important the windows are to the size of the air conditioning equipment, how important the orientation of the house is to the loads of the house and things like that. And so having those two things together, I think, is really what pointed me in the direction that I've gone. I ran a mechanical engineering department where we specialized in residential HVAC design for production home builders for 8 years. And in those 8 years, I probably conservatively did 2,000 to 3,000 designs on production homes. So these were houses that were, a subdivision had 3 or 4 models, plan types, and each one of those plan types could be built 20, 30, 40 times. So you were doing designs that were built many, many times. And I was very lucky that we did good designs. And I can honestly say that if they installed according to our design, we didn't have any problems. We got no callbacks, no angry homeowners, except for a few of the, when you have 100 houses in a subdivision, there's going to be 1 or 2 people that are going to complain about anything, no matter what. But we were able to resolve those pretty quickly. But it really taught me the design side as well as the actual performance side. I think a lot of engineers miss out on the commissioning side, the testing it once it's done side of it. And I think that's really, really important for people to get both sides of that equation and get that experience. So that's just what's gotten me to where I am.
You have real trust in the process.
Yes, absolutely.
Because of evidence.
Exactly. And one of the biggest things is airflow. When we drew our mechanical plans, we would show a register in each room, and we'd put a little box next to each register. And this box had 2 halves, an upper half and a lower half. The upper half, we'd put our design CFM. So if this room needed 160 CFM, that was in the box. And then the lower half was empty. And for this particular company, we had HERS raters. We had field techs that would go out and actually measure the airflows in the field, and they would write their measured number in the lower half of that box and send it back to us. We printed them out on 11 by 17 paper, and they could write all the numbers in, and we'd get those numbers back. And 99% of the time, the measured airflow was slightly higher than the design airflow, and that's exactly what you want. And it was just really rewarding to get that. Every now and then, we'd see one that was way too low. And we say, all right, what's going on here? Did we not size the ducts correctly or whatever? And so we'd have the rater go back and look at it, and they go, oh, no, the duct was kinked or it was crushed or something like that. And it was an installation issue that was causing that. And so just that whole feedback loop, it's been invaluable, really.
You have a lot of energy when you talk, and you have a very broad perspective to convey that. Are you hopeful with changes that have been happening? Even though you made the statement, we'll go with it, HVAC hasn't changed that much in 20 years. Does it need to change, or is it changing now?
It is changing. It needs to change a lot more, and I'm very hopeful. I think social media is going to be one of the biggest drivers of change, because just in joining a few Facebook groups over the last couple of years, I've met some amazing people. You've interviewed some of them. And there's still several more that you need to interview because they are really, it's the new cream of the crop. And I think their word needs to get out there. And installers really only respect other installers. Having ME at the end of your name is almost a disadvantage sometimes. And
Yeah, me.
yeah, exactly. Some of the installers out there, if I can mention names, Jenry Garcia and Eric Kaiser and a few of the others out there are just, people need to listen to them because they're doing it and they're proving that it works. And I hope that their word gets out, and it's thanks to social media is how I learned about them. And I hope other people are doing the same. So I am very hopeful. I think things are going to improve. The word needs to get out there. People need to respect the design process more. I've tested too many homes where they just installed by rules of thumb and it just doesn't fly. And the tendency when you design to rule of thumb is to oversize the equipment to play it quote unquote safe, air quotes safe. And then they tend to undersize the ducts because it's easier to install smaller ducts. And I've just seen that way too many people do it. And installers aren't willing to downsize the equipment unless they have some sort of assurance that it's going to work. And that assurance is doing a load calculation. And so it's been a passion or a calling of mine to just get more people to do load calculations. And I wrote a blog article back in 2013 called Why We Need a More Simplified Design Methodology. And it was a little bit of a dig at Manual D, but it was more a dig at the software that was currently available. And because I had been training, I had a contract through the utilities to provide free manual JS&D training to HVAC contractors. They even gave them free copies of the manuals. And if you've ever bought manual JS&D, those are expensive manuals. We would give free copies of those manuals to the people who took this class. It was sometimes a 3-day class and sometimes a 4-day class. And I just saw the look on their faces when they were going, this takes a long time. This is really complicated. So my first theory was, let's just come up with a really easy, call it a rule of thumb if you have to, but it can be much more than that. Let's come up with an easy way to do it. So I started working on that and then rolled into, all right, let's keep the same process. Let's keep the same design methodology, but let's have a much easier software that people can use. And that's how my son Connor and I got into our new software project. But originally, my goal was to just have an easier process overall that was based on the ACCA manuals, but really simplified it for the 70 to 80% of homes that don't need a really precise design. They just need something better than winging it. So that's just a little background on how our software came to be. And just one of my passions really is just to get more people to do good design.
Let's explore that. I'm going to throw a tag out here, Renaissance Russ, because for HVAC, you're an inventor, an author, a software developer, and a practitioner of design, and an instructor. Tell me a title you don't have.
Well,
I think I'm making you blush. We switched the video off, but maybe I'm making you blush here.
I've only installed 2 systems, so I don't consider myself an installer.
Okay. All right. Well, we'll scratch that one from the list.
I definitely need more work in that area. Yeah.
Let's explore that software development thread with your product with your son. Give us a little bit of background story on how that came about.
It stemmed from that blog article. I was hoping the article would prompt other people to take action in it. And about 7 years later, nothing happens. I said, all right, I guess I better do something myself. It's more like 5 years later. And my son, Connor, went to college at UC Santa Cruz and got a degree in computer science. And his dream job was to design video games. He'd already designed several video games and he went to college to learn how to do it really well. And he learned to program in a platform called Unity, which is a common, popular platform that a lot of really big name video games are written in. But they've also branched out into architecture and engineering too. But he was looking for a job and he was literally, his desk was, I could reach over and pat him on the shoulder while he was looking for a job. He was living at home. And I had this idea that I wanted to pitch to some people. And I said, Connor, can you make a little mock-up of a house, of a 3D house for me? And he said, oh, yeah, no problem. So he bangs it out in like 30 minutes. He goes, how's this? I go, that's cool. I go, can you draw some ducks? And I showed him what I wanted to draw. He goes, oh, yeah, no problem. So he bangs that out in 30 minutes. And I said, can you make it so I can change the size of these ducks? He goes, oh, yeah, no problem. So he knocks that out in about an hour. And I said, Connor, this is not a mock-up. This is exactly what I'm trying to get people to do. Let's do this. So I convinced him to start a business with me. And we started a company called Coded Energy. And that was in 2018. And I said, hey, stick with me. We'll pay you a pittance of a salary. You can live at home. We'll feed you, give a room and board, but you got to help me design the software. And it took us about a year and a half to put something on the streets. We released it in April of 2020. Oh, but a big part of that was we wanted to get it ACA certified. And that's a very expensive, time-consuming process to get software certified through ACA. And at one of the ResNet conferences, we ran into the folks from FSEC, Florida Solar Energy Center. And they have a program called Energy Gauge. And they had not too long ago got a module of Energy Gauge approved by ACA. So we met with them and we talked to them and we said, hey, we've got this really cool 3D user interface. We would like to team up with you and use your ACA load calculation module as our load calculation engine, if you will, runs in the background. And they agreed to that. And so that's just been a really fortuitous meeting at a ResNet conference of all places. And they're extremely smart people over there at FSEC, and they've been very helpful. And we have an agreement with them where it's a single download. You download it. It's called Quick Model with Energy Gauge Loads. It really is two software, but it acts as one. And you build your house in the 3D model, and then you run your load calcs, and this little window pops up that's Energy Gauge, and you enter some information there, and it does the load calcs. You close that window. All that information goes back into Quick Model so that you can then size your ducts and stuff like that. So it's been an amazing partnership. We really enjoy working with them. Connor actually went over there and spent a couple of weeks in Florida working directly with them and in their offices and got to know them very well. And that's all been great. If I could give anybody any advice, that is, don't release a software at the beginning of a worldwide pandemic. That makes it a little hard to market, but things are slowly but surely. Actually, it's been kind of a blessing in disguise. It's been a slow release, whereas it could have gone crazy and we find bugs when you've got several hundred users and then have to apologize to everybody. So fortunately, we only have to apologize to a few people every now and then when we find a bug or something, but it's been great. It's been really good.
And you've been using feedback from your users, and some of them are actually power users of the product to make it better. How does that go? How does that process go?
That goes really well. We make a point. Connor will literally reply to an email at 1 a.m. if somebody emails him and has a question. And I try to, if I can. We don't say, oh, it's after 5. We're not going to answer emails or texts or anything. Some of our power users have Connor's phone and they can text him directly if there's an issue or if they need something done right away. And we learn as much from them as they learn from us. And that's been great. And then some of them started their own, without our prompting at all, started their own Facebook users group. And that's been awesome too. So we monitor that. We try to answer questions. So I think the thing I'm most proud of is our response. When someone has a question, we get back to them immediately if possible. And we're trying very hard because we appreciate the feedback that we get so much.
How would somebody find the product, learn more about it? Where's the website or resources to find that?
Sure. The website is quickmodel.com, and it's KWIK model.com. That's our main website where you can purchase it and all that. But the best place to learn about it is on our YouTube channel. If you go to YouTube and just search for Quick Model, our YouTube channel will pop up, and we have probably 30 videos, demo videos, training videos, and all that kind of stuff. And if you want to learn about it, that's probably the best way if you want to get it. And we do have a 30-day free trial where you can download it and play with it for 30 days. It's basically fully functional. It's just that you can't, if you create a file in the trial version, you can't open that file in a regular version unless you send it to us and we convert it for you. It's just a 30-day free trial, and we get quite a few users doing it that way too.
So have any friends sent you models for houses where that's challenged you to create, say, odd looking rooms and roof lines?
Yes, some really bizarre ones. Those gables, I've come to really hate gables for some reason. No, it's just, the problem is that that's very hard to convey on a 2D set of plans and then convert it to a 3D model. And you do want to be as precise as possible and you want it to look good, but there is a certain place where you can make a model just as good by not being quite so precise, if you know what I mean. Some of the gables have all these really facets and corners and angles and stuff like that. And you can really get exactly the same number by just squaring it off and simplifying it. But when you're demonstrating software, you want it to look as realistic as possible. But there are shortcuts you can take, and you just learn those over time. And if you're doing a design and you don't have to show it to the homeowner where they're going to say, oh, that doesn't look exactly right. And then you have to explain why you didn't make it perfectly accurate. There's a lot of simplifications that can be done. And the other thing too that I've really learned over the years is that homeowners aren't as picky as people think. I would go out and do air balancing on these homes, and I know what the target airflow is for the house. And then I'll measure the airflow and I'll create a spreadsheet. And I'll ask the homeowner, without telling them my results, I'll ask them, what are your comfortable rooms and what are your not comfortable rooms? And they'll say, oh, this room is not comfortable. This room is definitely not comfortable. And I'll say, well, what about this room here, where I measured like 30% low on the airflow? And they'll say, oh, no, that room's fine. I go, really? It's 30% low of airflow. It's fine. They're like, yeah, that room's fine. It's the other ones that are like 60 or 70% low that are the ones that they notice. So I guess the point of that is homeowners' sense of temperature can be more forgiving than I think people realize. And you don't have to be quite so precise on the airflows, the balance and stuff like that. But at the same time, I don't want to discount that because you can really screw it up and cause problems. And the biggest issues I've seen have come from oversizing the equipment of all things, causing comfort problems where a homeowner is going to complain about something.
Along those lines, there's this thesis in my mind that I haven't quite been able to convey yet. And that's based on the results of having the new home we built modeled with the Passive House Planning Package, with Quick Model, with the Cool Calc by Michael Hausch. So all very reputable, integrated packages that give you results. However, you're designing a house and a system to accommodate a wide range of usage, load, and conditioning. And I think those are the three parameters I'm thinking of. And we actually touched on those throughout this course of the conversation so far. So you're trying to hit a moving target. And the usage, I think, is also part of the humanity aspect, the people that are in the space, like you mentioned. If they don't spend a lot of time in that one room, that even though it shows to be bothersome, it may not be bothersome to them because their usage is going to be different than if they were living in that room 24/7.
Yes. The other thing people don't realize is that the load on one room changes dramatically throughout the day. So in the morning, you've got direct sunlight on this room, but you've calculated the load for the afternoon. And it could be in the afternoon, it's on the shady side of the house and it might not be getting as much air. And so the key to making that work is to have your system running as much as possible, is to have that air circulating as much as possible. And that comes from slightly undersizing the equipment. Your system will run longer cycles than oversizing the equipment. Because as soon as you oversize and you start short cycling, that's when all those problem rooms start popping up. That's when they become more obvious.
It's also variable speed equipment versus single speed or even sometimes two speed, that you're going to have these stop-start situations where things are trying to catch up and overshoot and then delay until it has to try to catch up again.
Yep, exactly. One of the projects that I worked on that was one of the biggest learning experiences for me is I was asked to be an expert witness on a class action lawsuit against a builder. And I was on the builder side, so I was defending the builder against a bunch of homeowners in a subdivision. And what had happened was, well, first of all, the homeowners weren't happy with the comfort in the house. They had bedrooms over the garage that weren't cooling properly. And so the contractor couldn't figure out why it was doing that. And they hired an attorney. The attorney went into the Title 24 Energy Code compliance documents and found out that the houses had been modeled with rigid foam insulation on the outside. It was a one-coat stucco system, and it was modeled to comply with the Energy Code with this rigid foam insulation. Somewhere along the line, the builder decided not to put that in. And so that immediately said, oh, our equipment is not sized properly. It's undersized. Our air conditioners aren't working. And they go on and on and on. And so they were convinced that that was the problem. And so I had been doing design for this particular builder on a division of theirs in a different part of California. So they asked me to help them out. And so I went and did load calcs on these houses. And even without that foam insulation, the equipment was still 30% oversized. And so the homeowners were convinced that the equipment was undersized because they didn't have this insulation. It turns out they were still oversized, and that's what was causing the problem. And so what they ended up having me do is we selected 11 houses there's 3 different plan types. And so we had several of each plan type. And I put data loggers in each house. And these were good sized houses. They each had 2 systems in it. So I put data loggers, about 8 data loggers per system. And back then I was using the little Dixon temperature data loggers. They're about the size of a book of matches. And I'd put those around the house and they would record temperatures every 2 minutes. And I did it for 11 days on these 11 houses. And the design temperature in this town was 98 degrees. And during those 11 days, it hit 106. degrees. And those air conditioners were short cycling at 106 degrees outside temperature. And when I got all that data back, it was just mind blowing. Every house I looked at, I was like, oh my God, this is amazing. Look at these temperatures. Look at this short cycling. It was also a funny psychological experiment too, because some of the homeowners, they knew I was on the builder side. And so when I went into their house and put these data loggers around, they were going to do whatever it took to screw me up. And I said, don't touch your thermostat. Part of this test is that you cannot touch your thermostat. If you touch your thermostat, I will know, because I have a data logger that tells me when the system comes on, and I have a data logger right next to the thermostat that tells me the temperature of the thermostat. Some of them still would go in and monkey with the thermostat, even though I told them not to. They didn't think I would be able to tell. One of them, I think, took a blow dryer and blew hot air on one of the data loggers in one of the rooms because the temperature peaked at like 100 degrees, or they took it outside or something. It was crazy. But anyways, just all that feedback from those data loggers and seeing how oversizing equipment can cause serious temperature variations in individual rooms for a variety of reasons. And then the whole upstairs, downstairs stratification issues. And it was really, really educational for me. And I'm glad I had that opportunity.
And I think you struck on something there. It's homeowner education at a level that they can grasp what's going on and some of the complexities and some of the reasons why and things behind. I'm going to shift over to another one of your Renaissance roles, and that is of an author. You wrote a book called HVAC 1.0 Introduction to Residential HVAC Systems, and it was written really for technicians. I think you said for a community college course is the reason you wrote that book. Tell us a little bit more about that.
Yeah, it's used in community college courses. I wrote it for non-installer people, non-HVAC contractors. Back then, we were training a lot of HERS raters, and we were training HERS raters to be special inspectors for the California Energy Code. And part of that is going out and testing for duct leakage, testing for airflow, fan watt draw, and doing refrigerant charge tests, among a lot of other HVAC stuff. And there was a big program to re-educate people who had lost their jobs and things like that. We had people coming completely out of left field from completely different professions, and we're trying to train them how to test HVAC equipment. And they didn't know a plenum from a condenser from a register. That was basically why I wrote that book, was to really introduce the real basic stuff. There's a lot of utility personnel that deal with HVAC, but they don't have to work on HVAC. And so it was written for those types of people. But it's funny too, when I was teaching the class, it was sponsored by a utility. Half the class was HVAC contractors would come in to take this really basic HVAC class, and they got a lot out of it too. A lot of contractors are really good at what they do. And what they do is they install equipment, they hook up the electrical, they charge it. They're really good at that, but they have not had the opportunity to get the big picture. What does it all mean? How does this all fit into the big picture? So that was another reason to kind of write that book. And it's been a lot of fun teaching the class based on that book. It is used in a couple of community colleges as the introductory class. And it's getting about time. I'm going to have to put out a new release here pretty soon. It's getting a little bit out of date.
Yeah, things have changed. Where can people get the book?
Through Amazon and through your website too, I believe. If you're still selling it, I believe. Yeah.
Yep. I'll put the links in the show notes here, as well as links to Quick Model, the YouTube channel, and your blog. Another sort of aspect I wanted to pursue is that of an inventor, a product inventor. Do you want to talk about that a little bit?
In the process of training all these HERS raters how to test ducts for leakage, you have to train them how to seal off the supply registers. That's a big part of doing a duct leakage test, is to seal off the registers. And I'm basically a lazy person. And so I'm really good at figuring out the easy way to do stuff. So that's what makes me a good inventor, is because I'm trying to avoid work, I think. I came up with this idea of basically it's a wooden pan with a rubber gasket around the edges of it, and it goes over the end of a spring-loaded pole. And these poles are made by Zipwall. They already exist. And I was at a trade show and I saw these Zipwall poles and I thought, oh, this will work very nicely. And so I basically make the pans. It's a wooden pan and it covers a register, and they come in different sizes, and you can walk around and just put them up, and the pole pushes up on them, assuming you have sealing registers. The pole pushes up on them and seals off really well. And so you can seal off all the registers in a house really quickly with it. There's other products that are similar to it out there. Ours is called Duct Block, DUC-BLOC, Duct Block. And if you go to ductblock.com, you can find those there. But there's other similar products out there, but the other products actually pull on the register. They have a little elastic cord and pull on the register. And in some cases, those work great, but we've had issues where, especially in older homes, we test a lot of older homes, that the ceiling registers are barely holding on to sheetrock with a couple screws. And it doesn't take much to pop those out of the ceiling. And then also sometimes we test homes before the registers go on. And so duct blocks press over the opening of the hole. And it comes with two 20-foot poles and a bunch of 12-foot poles. And yeah, it works real good. And so we market and manufacture that. A friend of mine actually builds them. I used to build them myself in my workshop. I have to use the other side of my brain sometimes and be hands-on and do woodworking and stuff like that. But I've been too busy lately. So a friend of mine's building them now.
So that's a perfect segue to your hobbies, some of the fun facts, the different things that people might want to learn about you.
Sure. As my wife say, oh, no, not another hobby. Because honestly, I attribute it to being a Navy brat. And from the time I was born until I went to college, my family relocated about every 2 years. So I went to a lot of different elementary schools. I went to 2 different high schools, graduated from high school in the Aleutian Islands of all places. There's a Navy base out there, and was just exposed to a lot of really interesting people with interesting hobbies. And fishing, woodworking, all that kind of stuff. But one that really stands out, I think, is when I was in Alaska, my senior year of high school, I had an internship with the Aleutian Islands National Wildlife Refuge. And that was why I wanted to become a wildlife biologist. But I got to band and trap bald eagles with the biologists. I don't know if you remember the old TV show, what was it called? Mutual of Omaha's Wild Kingdom with Marlon Perkins. Do you remember that show? At the beginning of the show, they had what's called a cannon net. And this net would shoot over a flock of geese and they would capture all the geese. Well, that's what we used in the parking lot of the Aleutian Islands National Wildlife Refuge. We'd put out a bunch of meat from the butcher and all these bald eagles would land, a bunch of bald eagles and ravens, and we'd shoot this net over them and catch 8 or 9 of them in one shot. And we'd go out there and we'd band them. And one of the biologists was doing a big study, and the way they would mark these eagles, these beautiful white-headed, white-tailed bald eagles, they would spray paint the tails fluorescent colors. So you had these fluorescent bald eagles flying around with these brightly colored tails, and that's how they would identify them from a distance. But anyways, I got some very, very hands-on, close-up contact with some of the most spectacular birds of prey, and that really started my love of birds of prey. Then when I was in college, I ran into a guy who was a falconer who actually hunted with falcons, and that got me interested in that sport. And so shortly after I got married, I got licensed. You have to be an apprentice for 2 years and have a sponsor and all that other stuff. And I flew red-tailed hawks, chased jackrabbits and squirrels and pheasants and all kinds of stuff. And I did that for 12 years and actually achieved the status of master falconer if you can do it for 8 years and fill out all these reports and paperwork and stuff like that. So that was an amazing hobby, I guess you'd call it. It's a sport, it's a hobby, but it's very, very time consuming, as you can imagine. And when my 2 sons started getting a little older, I gave that up to be more focused on being a good dad. So that was fun.
And you did mention the woodworking that dovetails with the duct block, but we didn't talk about yet the other aspect of authorship beyond technical. You wrote a book, a fiction book?
Yeah, it's a sci-fi novel, basically. I love to tell stories. I don't know. It runs in the family, I guess. I have a lot of stories to tell about my time in the Aleutian Islands and just all the amazing things, trapping the eagles, just all the exposure I had to various stuff and just being in such a unique location. If you get a chance, just Google ADAC, A-D-A-K, ADAC, Alaska. That's where I graduated from high school. It's phenomenal when you see it on Google Earth. So people are always telling me, oh, you need to write a book about your time in Alaska. And I don't want to write an autobiography. I don't want to write a book about myself. And so I came up with this idea to write a sci-fi novel about someone very much like me who lived on this Aleutian island and encountered these kind of little mythical creatures that no one knew about. And he accidentally gets captured by these little creatures and lives with them for a time and helps them out. That's what the story is based on. It's called The Nantuck of Adak Island. And the Nantuck are the little creatures. And it's this high school age person who encounters them. And so that's what the book is about.
How would someone find that book?
It's on Amazon. It's an ebook, Nantuck, Nantok, Nantuck of Adak Island.
Awesome. Well, we covered a lot of ground here today. And I think going back to our topic sentence that HVAC design hasn't changed much in 20 years. And you did touch upon it is changing now. Let me ask you from your perspective, what does the future look like? Maybe 5, 10, 15 years down the road for HVAC?
I think design is going to become much more common and much more appreciated. It'll become a more standard practice to do a decent design on houses, as whoever would have thought that if someone's furnace broke down and you just want to go out and swap out a box and maybe the air conditioner too, who would have ever thought that you would do a load calc as part of that work? And people are actually doing that because they're saying there's a very good chance that your equipment is oversized. And if we put in smaller equipment, guess what? It'll work better. And oh, by the way, your ducts will be more appropriately sized, to that equipment. And so there's real opportunity there. But the key is we have to make it easier. We have to make it simpler. We have to make the process of doing load calcs just all around easier and faster. And so that's a main goal of our software to do that. And I think it's coming from the other installers, HVAC contractors who are going, hey, this works. I'm seeing results from this. This works. It's not as hard as people think. And that's where the change is going to happen, is it's going to hopefully go viral. And it's going to come from social media. And that HVAC school blog, I don't know how many members are on that. And you're starting to see more and more and more people.
Tens of thousands.
Yeah. Post about how design works for them and how important it is. And I think that's how the word's going to get out there.
I've seen more change in the last 5 years than in the 25 years in this industry before that. And I'm very encouraged. And I think, like you said, social media is allowing people, common-minded individuals, to interact and to synergize. And then with people like yourself, who I wouldn't call it a silent mission, but you're on a very serious, steady mission to change the industry from your perspective, from your attributes, and you're doing it, man. Thank you.
Oh, you're welcome. My next target is architects. Is to get them on board, to get them to appreciate what's going on. And I think having a 3D design is going to help that a lot. It's going to help them visualize it. It's going to help them appreciate what it takes. And also a software program that they can use. Let them do a really simple design, if for nothing else than sizing chases in the house. And so I'm hoping that's my next target, really, is to get the designers of the homes to accommodate the duct systems more. The few architects I worked with in my career that appreciated what we were doing and understood the importance of providing room for ducts made life so much easier for everybody. The contractor loved it, the designer loved it, and the homeowners loved it. You just have to build that appreciation in all aspects of home construction.
So we've talked about ducts. What about unducted mini splits, basically? What's your take on that in terms of the application of them in the industry?
I think they're great. The California Energy Commission is having a little bit of issues with them. The Energy Commission doesn't like how they're tested and their reported efficiencies. They've done a lot of real world testing, and they're just not getting the same efficiencies in real life that the manufacturers are claiming. And that's a very contentious issue right now. And I probably need to be careful about how I talk about it. I'll get some nasty phone calls. But conceptually, they're a great idea. Ducts are a huge source of loss of efficiency, a loss of BTUs. And if you can get rid of those, one way is to bring them into the ducts inside conditioned space. That helps a lot. The other way is to get rid of the ducts. But you really, if you're going to have an unducted system, you're only conditioning the room that equipment is in. That conditioning has to somehow get through the doorways to those other rooms. And in order for that to work, it has to be a very, very efficient shell. So they work great on efficient buildings. They don't work nearly as well as a retrofit in older buildings because of that issue. They do make ducted mini splits. I think those are cool. I'm actually a big proponent too of the small duct high velocity systems like Unico. I took their factory training and I was thoroughly impressed with their systems too. But yeah, I think the biggest problem with what we call mini splits is the technology and the application being appropriate to that type of equipment. And if that's all good, then they're great.
And my house uses a small duct medium velocity system with a ducted mini split. So it's a hybrid. And I think some hybrid designs and concepts are developing. There's a couple manufacturers out there using more. When I show people that are non-HVAC people in my house, it's these hoses are what is supplying the cooling or the heating to the room. And they look like hoses. So they're air hoses.
Yep.
I know you got an appointment, so I'll let you go and give our listeners back their ears, but this has been thoroughly enjoyable. I always enjoy chatting with you and glad you came on this podcast. And I hope that I can do in a small way, help spread the good word and the good things that you're doing out there. So thank you.
Thank you, Bill. We really appreciate it.
All right. Well, take care, Russ. Thanks for listening in to this episode of the Building HVAC Science Podcast. There's a lot of great resources out there. HVACR School, HVAC Shop Talk, HVAC Reefer Guy, Tool Pros, Service Business Mastery, Quality HVAC, HVAC Overtime, HVAC, our videos, and HomeDiagnosis.tv. And of course, all the good stuff that Jim Bergman does out there. I also host a Res Talk podcast. Look that up in your app sometime to get a little different perspective. Well, that's talking about the world of home energy ratings and peripheral topics. I encourage you to subscribe to the podcast so you get this late-breaking information as soon as possible. And I want to thank you for listening and hope you grab some interesting perspectives from our guest, Russ King. If you want to keep up with other things I find interesting, follow Building HVAC Science on Facebook. And if you're interested in communicating with us, with me directly, send me an email, bill@truetechtools.com. Building HVAC Science Podcast is a production of True Tech Tools Limited, and the thoughts are those of the speakers, whoever they are, me and our host or guests included. Thanks for listening, and we look forward to having you back to listen more to the Building HVAC Science Podcast. Take care.